In this assessment, we're asked to show all possible constitutional isomers of C5H12O and label them as functional, positional, or chain. I've gone ahead and shown the answer here. The takeaway message from this assessment is the idea of isomerism and just reminding us what isomerism is. And so rather than work through and show you each one of these and draw them out myself, I've posted them here. Let's talk through how we might have come up with it. First of all, we recognize that there are two possible functional groups that can happen with C5H12O, alcohols and ethers. And so up at the top are all of the alcohol functional isomers. Within that functional group of the alcohols, we can use different chain sizes. So you'll notice that in this top row, we have all 5 carbon chains where the hydroxyl group has moved from the 1 position to the 2 position, to the 3 position. By shortening the chain and now including a methyl group on the 4 carbon chain, we have our second row. And now we move the hydroxyl group from the 1st carbon to the 2nd carbon to the 3rd and then to the 4th. And so we see that the top row of alcohols relative to the middle row of alcohols are chain isomers because our chain is shortened. Within each row, we've moved the hydroxyl group, so those are positional. We have one more that we can do, and that's to make the 3 carbon chain with now 2 methyl groups coming off. There's only 1 positional isomer there. We can't move the hydroxyl group from the 1st carbon over to the 2nd carbon. Essentially, we can do the same thing with the ethers. We can have a 4 carbon chain with a methoxy group with 1 carbon coming off of this oxygen here. Sorry, the Weatherman effect is not letting me point, with 1 carbon coming off of the oxygen. So the oxygen with a 4 and a 1 on either side, or we can have the oxygen with the 3 and the 2. And so that would be an example of an ether functional isomer. We can look at the chain isomers by taking that 4 carbon chain that was here and in the second row turning it into a 3 carbon chain, but with a methyl branching. And so those would be examples of chain isomers. And then so again, the final thing, the last one here is to have the 3 carbon chain here and a 2 carbon chain on the other side. And so by process of elimination, you can continue to move the ether group around, change the branching on the chain, and you generate those. So once again, the set of isomers here and here are functional. Within each functional, we have 3 sets of chain isomers for the alcohols, 4 for the ethers, and then the positional isomers. Where is that alcohol group or ether linked on the main chain?